This session this afternoon. This is a 45-minute talk. We've got Lennart Regebro here. And Lennart has been working full-time with open source web development since 2001. Since 2007, he has been an independent contractor. And today, he's going to blame it all on Caesar and tell us what we need to know about dates, times, and time zones. So let's give him a warm welcome.
Thank you. Yeah, I've been doing web since since the 90s, but with Python since 2001, and since 2005 on and off I've done a bit of calendaring stuff. I had to implement a calendar for a customer, and I then more or less ported or rewrote another calendar for Plone. So I've done a bit of calendaring things and gotten a bit fascinated, what people say, an unhealthy obsession with calendars. And calendaring, it's about keeping track of time as measured in 3 celestial cycles, the day, the month, and the year. And the problem with calendaring is that none of these cycles fit evenly together in each other. And that leads to a lot of complexities, and you have to solve them, and there's various ways of doing that. And one place that we've seen pretty much all of these solutions is Rome. So we're going to do a quick history of the Roman calendar here. It started out with the calendar, usually called the calendar of Romulus, which was 10 lunar months long and had 2 to 3 months of uncounted time in the winter. This is an unusual solution, but there's also a tribe in Canada of Indians that used the same, although they had the uncounted time in the summer, but doesn't matter. And this works, you know, if you're a farmer, but it doesn't work if you're a civilization. So when they're trying to get to be an empire, this doesn't work anymore, and they replace the uncounted time with 2 months called January and February. And that makes the Roman calendar a lunar calendar. And they move out of sync with the seasons of 10 or 11 days per year. So to solve that, you introduce leap months in lunar calendar, and then you get lunisolar calendars. This is the most popular kind of calendar through history. Most calendars have been lunisolar because they keep track of both the moon and the sun, which are the two big things in the sky. But they're very complex, and the way to calculate when you're going to have a leap month is a big cycle that's like 17 years, except when it's not 17 years, and so really, really complicated. But what's worse with the Roman calendar is that it was actually decided and controlled more by a combination of politics and superstition that has given also us such wonderful things as the Chinese Cultural Revolution and airport security. So you can understand it wasn't very good, and it seems to have been 2 to 4 months out of sync by 50 BC. So you're in a situation where actually the season is out of sync with the calendar of several months. So that's not good, so that's where we get our first villain of the talk. The main villain is Gaius Julius Caesar, who tries to fix the problem by creating his own calendar. And he drops the leap month and instead increases the lengths of the month to compensate, and that means there's no longer any connection between the moon and the month, so the calendar is now a purely solar calendar. And because solar calendar drops this synchronization to the moon, they are a lot simpler than lunisolar calendars. But although the Julian calendar drops the leap month and replaces it with the leap day, it keeps all the other complexities. And he's a villain because he knew about the Egyptian calendar, because he conquered Egypt and got also conquered by Cleopatra. And the Egyptian calendar, they had 12 months of 30 days each, with a little holiday of 5 to 6 days at the end of the year. It's much, much simpler, but for some reason he didn't use that, and that's highly unfortunate for us. Instead, he takes the old Roman calendar that had a mix of 29-day-long months and 31-day-long months, because even numbers are unlucky, and moves them to be 30 and 31 days long, because apparently it's not unlucky anymore. I mean, things have happened. It's hundreds of years in between these two calendars. Except for February, then that's 28 days, except unless it's a leap day. And that means we end up with months that are 28, 29, 30, or 31 days long, according to very complicated patterns. It also ends up with a leap day that is inserted in the middle of the year, not the end, which adds more complexity. And he also renames a month after himself, because he can. And thanks to the success of the Roman Empire, the Julius calendar gets forced to many unsuspecting folks around the world, despite being pretty much the worst calendar ever made. It's lasted for 2,000 years with only a minor upgrade in how to calculate leap days, making it to the current Gregorian calendar. And that's proof that quality doesn't beat marketing. But it's a really complex calendar, and it means you need to keep your tongue straight. Let's talk about, for example, the leap day. Having a leap day is unavoidable because the year is about 365 and a quarter days long, more or less. So you have to have this extra day to keep it in sync. But you don't have to insert it in February the 24th, which is the day it used to be. The reason it's the February the 24th is lost in history, more or less, at least. And they mostly switched it to be the February the 29th nowadays, except in Hungary. And I think some other Greek Orthodox countries, But this is, you don't have to despair about this, because this is just the start of the complexity when it comes to calendar. Because what day of February the leap day is only matters for name days. If you have calendars that have each day dedicated to a saint, or you have a special name and you have name days like you do in Scandinavia and many European countries. Otherwise, you don't have to care about it. The problem is instead that it's in February, that it's not an extra day added to the end of the year, because that would make all of these calculations much simpler. And that you have arbitrary lengths of months doesn't really help either, and the week handling that the Gregorian calendar has is just really rubbing salt into the wounds. And I haven't mentioned weeks because it's not a celestial cycle, it's just an arbitrary grouping of days. I mean, the Romans had an 8-day week and Egyptians had 10-day weeks, and but the 7 days from Judaism has prevailed because it's a good length of a week. But you can handle it in different ways. You can restart the week cycle at the start of every year, for example, if you want to. But our week handling doesn't do that. It's continuous, it's a separate cycle, and that means that even though we dropped the month and the synchronization to the moon, we now have to care about weeks that are in an independent cycle and doesn't actually fit into the years. If you instead look at the Egyptian calendar, it splits each month into 3 10-day weeks with this 5 or 6 day holiday at the end, not being a part of any week at all. And that means calculating things that day of the year, day of the week, and the week number is this code. And you can't see that in the back because it's small, but that's just there for comparison. You're never going to have to implement the Egyptian calendar, so it doesn't matter. And most of the complexity here is actually adding 1 and subtracting 1 to keep the day 1 of a month and a year being 1 and not 0. So that's most of the complexity here. If we instead compare with the Julian and Gregorian calculations for this, they are very complex and each have their own very long Wikipedia page about how to do this. This is the simplest way of doing it, and it's simple because it uses 3 pre-calculated lists you see at the top there. And so the rest is just basically adjustments for the leap days and things like that. So it's just minor adjustments. But what does this then mean for you as a programmer? Well, it means that you shouldn't try to do this yourself. You should use a library. And this means there's even simple things that you think, well, I'm going to get the next day. You cannot just take the day number and add a 1 to it, because then you have to start checking, is this the end of the month? And when is the end of the month? Is it a leap day year this year or not? And is it actually kind of maybe December? So if we fold over to the next month, we have to check if we're going to fold over to the next year again. You have to use a calendar a library that can do arithmetic. So you can say add 1 day to this date. That way, it's somebody else's problem. In Python, we have this. We have the datetime library, which is not perfect, but it's very good. And it has, of course, both date objects, datetime objects, and time delta objects. So you can create a time data object that is 1 day and add that to a datetime, and you'll get the correct date out. In JavaScript, there's basically nothing built in, so you need to use a library. I haven't used any of the libraries enough to actually say that this is the one to use, but people in general seem to agree that Moment.js is the good one for JavaScript. And it looks okay, except that it continues to use what Java and JavaScript does. It has 0 indexed months. And that means that January is 0 and December is 11. And that confuses everybody all the time. It's nonsense. And whose fault is this then? Well, we have villain number 2 here, and that's James Gosling. Here putting cream in the face of a Bill Gates imposter. And one of the first pictures that shows up of him when you Google his pictures for him. So that's why I chose it. Now, of course, James Gosling is not stupid. He just slipped up and made a mistake. Everybody does that. But when you do it in an API or in a language, you have to live with it for a very, very long time. And the only way to fix it now is to create new whole date objects, which should be done in both Java and JavaScript very soon. And it's likely to happen never. It also does something else wrong. It starts the week with a Sunday, because Americans have this idea that the week starts with Sundays, which also makes absolutely no sense. But since the most popular start of the week globally is Monday, it's also uncommon to have the default first day of the week Monday and giving 0 for that. But that is not only, again, inconsistent with how people usually count, which starts at 1, and inconsistent with how dates and months works in general. It also means that in the United States, the first day of the week from a human standpoint is the 7th day of the week from the computer standpoint and has the number 6. And everybody gets confused with that all the time. Therefore, ISO has determined that Monday is the first day of the week, it's day 1, and Sunday is the last day of the week and day 7. And that's why you should use the ISO weekday function when you use the Python datetime library. Using 1 for Monday also has the benefit that Sunday could be day 7, or it could also be day 1, like it is in Java and JavaScript, which at least makes some sort of sense that day 6 doesn't. So in your calendaring code, you should use ISO weekday, you should have Monday to be 1, and I usually try to accept both 0 and 7 for Sunday, just because then you can, for example, just pass in JavaScript's variable directly and it will work. But you should return 7 for Sunday, or 0, but never 6. And if that wasn't confusing enough, it's now time to talk about time zones and time to debunk a myth. The world is not split into 24 time zones. There have been several proposals to do that, but it's never happened. Instead, every country has decided to adapt its own standard time, and they have done that at different times. In the case of big countries, many standard times. And results of this situation is that Nepal, for example, has a standard time of 5 hours and 45 minutes before GMT. And Sweden, between 1879 and 1900, for reasons that are not entirely clear, was 1 hour and 14 seconds before GMT. I think it's probably just a question that they measured the distance wrong. We're not entirely sure. A time zone could be defined as an area that has the same standard time, but what the same means is a matter of taste, and it's made worse by standard times varying throughout history and throughout the year, thanks to the absolutely most evil thing in calendaring, which is daylight savings time. And this is the guy who caused this. He's not the first one to invent daylight savings time, but he's the man who made it happen, because he was the first one who had money and connections to make it happen. And he made it happen because he thought other people were lazy and should go up as early in the morning as he did. And that is not a joke. It's true. He was out in his early morning ride on his horse and noticed that nobody else was awake and decided that this had to change. And since time zone rules for different countries change between different years, you need to have a database over all the changes, or you can't do proper date-time calculations in the past. And such a database exists. It's called ZoneInfo or TZ or the Old Zone database. ZoneInfo also solves another problem with time zones, namely the problem of naming them, because since time zones doesn't actually exist, they don't have any standard names. Instead, they're usually called some abbreviation like GMT, UTC, CET. And these abbreviations always have a T in them, and they usually also have an S for standard, and that doesn't leave that many abbreviations in total. And that gives us these effects, right? So when you talk about CST, what are you talking about? Are you talking about Central Standard Time in the US, or Central Standard Time in Australia, or China Standard Time, or Changyang Standard Time, which is what they use in Taiwan, but since Changyang is actually on the mainland, they're starting to call it Central Standard Time as well. So expanding the abbreviation doesn't really help, because even there's 4 CSTs, but there are actually 3 different Central Standard Times. So the ZoneInfo database does this. These are the CST database, CST time zone names in the Old Zone database, or the where you have the continent and city. Actually, the city is unique, but I guess they put in the continent there to make sure that sometime in the future it would continue to be unique. But the city names are unique in the standard time, in the database. But these are political regions. These time zones in the Old Zone database are political areas. It's not geographical areas, for good reasons. There is, for example, no special zone for the area of Poland that was German before World War I. So if you calculate the time for Wrocław using Europe-Warsaw as the time zone, you'll get 1 hour wrong dates between the 15th and 30th April during the war, because Germany and Poland had different daylight saving dates. And there's also no special time zones for political entities that only existed before 1970, but I haven't actually figured out if there are any political entities that only existed before 1970 that had any standard times, so I don't know if that's a problem. It also took some time to tweak the whole daylight saving thing, because in the start they usually switched at midnight, or at 11 or 1 p.m. actually, they usually switched it. So at 11 o'clock they switched to 12 o'clock, or they switched to 1 o'clock at 12 o'clock, or at 1 o'clock they switched back to 12 o'clock, and stuff like that. And all these things are bad ideas, not only because people are quite often still awake, but also because you sometimes have no midnight or you have 2 midnights, and that confuses the computer very much. For example, a common way to check if a date is valid is to create a date object with the date information and see if you get an error. And that works fine in Python. You'll get a day is out of range for month, date. JavaScript is a bit trickier, because if you create the February the 29th, you'll actually get 1st of March back. So you have to check if the date is valid. You have to create the object and then check that you got back what you wanted. And this leads to the problem, like in the Rome time zone, if you create the May 28th, 1972, remember that 4 is May, this becomes an invalid date, because midnight that day doesn't really exist, because it switches directly from midnight to 1 o'clock. The problem is that some C library somewhere handles this incorrectly for some time zones, and I haven't checked now the last couple of months, but nobody seems to really know where this happened. But somewhere it actually switches back 1 hour instead, and the date you get back is the 27th of May. So when you then do the check, that you got back the date you asked for, you don't get back the date you asked for, and the check will say that 28th of May 1972 is incorrect if you have Rome as a time zone. And this leads to the interesting problems that people who are born on this date can't check in on Italian websites, or on airplanes. So to avoid this in your JavaScript code, you have to add a couple of hours to the check. I recommend that you add 12 hours and check noon, because there's no risk that it's going to be a problem. Python, of course, doesn't have this problem, not only because it has a date object that doesn't care about time zones, but also because Python stores the local date and time internally. But that has another side effect, which is much smaller, and then we have to talk specifically about Python and time zones. And the datetime library has support for handling time zones via the tz-info type, but it's an abstract implementation. You can create tz-info objects, but as soon as you try to use them, you get a not implemented error. In 3.2, you have a time zone class that used fixed offsets, so you can create a fixed second offset, but you don't have any support for the zone-info database. There's a PEP, which I wrote, which I hope to implement during the sprints here, and get into Python 3.4 to have full support for zone-info. It's going to be based on one of the existing datetime libraries, namely PyTZ. Because there's two of them at the moment, PyTZ or dateutil. You have to excuse me if I mispronounce PyTZ, because I don't know if it's because I'm from Sweden. I have a tendency to call it pits. But everybody else calls it PyTZ, so I'm going to try to do that. So I will have a little shootout here. And PyTZ, both of them wrap and include the zone-info database. But PyTZ is released every time the zone-info database is updated, which is several times a year. dateutil is released when they have bug fixes, which means that the zone-info database in dateutil is usually outdated. So 15 love, I think you say, in tennis. On the other hand, dateutil will use the OS-provided zone-info database as by default, while PyTZ will not. And the OS usually keeps that updated, so it evens out. On the other hand, on Windows, there's no zone-info database. So, but dateutil has functions to parse dates that have time zone support, so that's good. On the other hand, when you move from daylight saving back to normal, the clock is moved back 1 hour, and that opens up for a very important question, namely, which 2:30 do you mean? Because you get two of them. And the way to solve that internally is to always use UTC for all the dates. So even if when Python has time zone support, or you using PyTZ or dateutil, you should always internally have UTZ dates and only change them to the time zone you want to display them in when you're displaying them, when you're outputting them. Because otherwise you get these problems that you don't know which 2:30 you're meaning, really. And even so, if you do this, you should still try to avoid scheduling meetings during DST changes. But if you have international companies, this will sometimes happen, or because people have to stay up in the night to make the meetings. You'll also have date inputs. People are typing in dates, or you import stuff from a log or stuff that could be in local time zone. So what you have to do then is to be able to specify if it's in daylight saving time or not. And PyTZ supports this by this isDST flag they have here. So you can set that to true or false to specify if it's DST or not, or you can set it to none, which will give you an error if you specify a time that is non-existent or ambiguous. you'll get an error. So if you specify 2:30 during a changeover where 2:30 happens twice, and you have ist equals none in PyTZ, you'll get an ambiguous time error. Usually you don't want that, but if you for some reason need to be really anal about date times, you have that feature in PyTZ, and you do not have it in dateutil. So that's a nice little touch. It's also not always possible to figure out what the local time zone name for your computer is. And with PyTZ, you have to figure that out, because when you want, if you want your local computer's local time zone, you have to still give the full zone info name to PyTZ. But dateutil has handy classes to use the local time zone, even if you don't know what it's called. So then it evens out again. But I wrote a module called tzlocal that fixes this for PyTZ. So with tzlocal, you can get the local time zone info, either the name or a class with the local time zone info. Because on some Linux versions, you just cannot figure out the local time zone name. It's not possible. So PyTZ kind of wins just a little bit, but they're both good. And as I said, the PEP for including time zone support in Python 3.2 is 3.4, sorry, is based on PyTZ. Although the API will switch back to the normal one because PyTZ has a special API. Yeah, so since the standard lib doesn't contain any real time zone support, it will not help you to parse date and times, but dateutil will, as I mentioned, and it's quite intelligent about the format. So if you, for example, it supports a lot of formats, and it will do very good guessing of what you mean with the format. So if you parse in something you might get from a log, like the RFC 822 format like this, you'll get a datetime out with the correct time zone offset. Also supports the POSIX format, and as you see, you get the same. The only difference is that GMT minus 300, and you get the same data back. Oh, wait, what? No, you don't. It doesn't say minus 10,800 seconds anymore. It says plus, because the POSIX format has got minus and plus backwards. This is an important thing to know. It will also bite you if you have POSIX stuff and you're not using a parser. But POSIX has this minus and plus on GMT. So it says GMT minus 300, you get GMT plus 300 back. Yeah, somebody made a mistake again. I don't know who. I can't put up a picture of them. Parsing dates is, either when you input dates, but often you have date inputs that solve that, we'll come to that, or if you talk to other systems, log files or stuff. The most complex date parsing and parsing at all is iCalendar, which have two RFCs. The later one, RFC 5545, is less complex than the first one, but everybody is still using the first version, so that's the one you have to support. And since iCalendar is designed by the Internet Engineering Task Force Calendaring and Scheduling Working Group, you realize that it's designed by committee and very, very complex and not very good. For example, you can find an event with a start date that has several recurrence rules that run in parallel, as well as a list of specific dates outside that rule where it should also happen, as well as recurrence rules where it should not happen, even though it happens in the previous rules, and dates where it shouldn't happen as just specific dates. And why would you want that? Well, I've heard a rumor that it's the Python Secret Underground needed it for their meeting schedule. But since the Python Secret Underground doesn't exist, it can't be true. I don't think anybody has actually used it. And to make things even more fun, the recurrence rules in themselves are very complex. Of course, you need to have, hourly, daily, weekly, all this, secondly and minutely, not really useful in calendaring, but okay, it's there for completeness. But what does it mean if you have a monthly recurrence rule by hour? I don't understand it. This table here only tells you if you get less or more events. And then there's pages of explanation of what this actually happens in the specification. And note 1 and note 2 there are also interesting. It's like, okay. So I don't know why they support this. This is just crazy. The recommendation again is to use a library, and if you use Python, you are in luck because there's a good library and it's part of dateutil. So this is again another reason to maybe use dateutil instead of pytz, because dateutil has a lot of other features like recurrence rules. Using time zones in iCalendars is, though, very complicated because you can't just specify it like this, because Microsoft was part of the committee. And Microsoft has different names of time zones. So they don't have any sensible, like America, New York, or calling something Europe, Paris. No, that time zone, Europe, Paris, is called romance time. If Rome was a part of the time zone, I could maybe understand it, but it isn't. It's just like really, oh well, it's Paris, that's romantic. So. And there's also both, I think, an Eastern Europe and an East Europe time zone. So you have to define the time zone with all the time zone rules in the iCalendar, and this looks like this. It's very complicated. So what to do? Well, don't do it. Just use either the first form, which is that it's in UTC. You give the date in UTC and let your calendar application convert it to the local time. Or you just put it in local time, which is the last format there. So you just don't specify the time zone. The local time then will mean that if somebody imports this iCalendar file in some completely different time zone, it will be shown in their time zone instead. So this is a choice you have to do. At least you don't have to parse and generate the iCalendar files yourself. This is also kind of complicated. It's not that bad, but there's a lot of edge cases. There's an iCalendar module. Doesn't support Python 3 yet, unfortunately. Some edge cases have bugs, but it's generally good enough. All the problems of dates and time come together in calendaring in general, and other considerations that I haven't mentioned here is, are you in your calendar application going to support time zones at all? It's much easier to not do it. Or if you support time zones, are you going to support events that doesn't have any time zones that are all in local? Because that makes it even more complicated. Are you going to have different time zones for start and ends? Because sometimes you might need that, but usually not. How do you do whole day events? You really need that. They usually don't want to have a time zone, but maybe they should have a time zone. This is all just things you have to decide for yourself. The user interface is also very complicated. There's lots of different things. You know, you have lists. Should you just show the upcoming, or should you have a separate previous list? Day, week, month, and year views. And the trick there is to try to use as much libraries and existing stuff that exists. Date inputs, the best way to input the date is just to have a normal text field, because then you can type in the date very quickly. Problem is, people don't know what format to type it in, and even if you show the format, they will not understand what that means. So that's always going to be a problem. The solution to that is usually date pickers, but they are slow to use if you want to input a lot of dates, and they're not accessible for people who have various handicaps, because they require JavaScript. Drop-down lists are also slow, but they are accessible, but also doesn't allow you to type in dates. This is Plone's dropout list. You can have a combination, which Plone has. You have both a date picker and a drop-down list, so you can choose. Choosing time zones is a problem. One problem with drop-down list when you pick date times is that you have 60 minutes. It makes for a very long list. Plone solves that, but only listing every 5th minute. When it comes to time zones, you get an even worse problem because there's about 400 of them. It makes for a very, very long list. So this is why you see this kind of solutions in operating systems. But this is very tricky to do in the web if that's what you're doing. So you have a problem there again. This is an example of a month view. This is for web. It's called Full Calendar, this one. It's pretty good. So if you're doing web stuff, I can recommend you to check out Full Calendar if you need to do calendaring stuff. It has the problem that it only shows the middle of the day, which is good by default. That's what you want. But it has no indication if there's an event that is outside of the current view. That's the only problem with it. Otherwise, it's pretty good. Here is the recurrence input widget I wrote based on jQuery and compatible with jQuery tools and stuff like that. And the recurrence inputs are really, really complicated. It took a long time to do this, and I always make a note of thanking Hexagon IT in Finland, who paid for the work of doing this. It's not only me who did it, I should say. I did most of it. Some other people like Rock Garbers, and a lot of people have helped doing additional stuff. And this one will show you the dates that it will happen on. So when you change the rules, it will actually show you a list of the dates, and you will do that by doing a JSON query. With this little Python server, it's all done in JavaScript except for the little Python server that you can run. That's an example. And that's it. I've promised several times to make a list of blog posts of things that are actually interesting with calendaring that doesn't fit in this talk, because it might be interesting but not useful. But I haven't gotten around to do that. I'm hoping to get some time during the next few days to write these blog posts. This is my blog if it happens. So, are there any questions? Yes.
Is this on? Can you hear me? I have 3 questions, but there are other people, so I'll just ask one. Suppose I'm extremely eccentric and I want to personally use the Egyptian calendar. Are there good implementations out there?
I haven't heard of it. I mean, I know that there are. I've seen calendaring libraries, but I think it's probably for like C and stuff that do other calendars. I have this idea that maybe someday when I get retired, I'll write a Python library that where you can implement your own calendaring like plugin with the rules for it. But I haven't seen any Python implementations, and I haven't seen anything specifically for the Egyptian calendar. I've seen implementations, but I think it's either for C or Java or something like, or from the Hebrew calendar or things like that. The Egyptian calendar, I haven't seen any now.
Thanks.
I've got a library that I'm going to be working on the sprints actually to open source that uses the publicly available geographic shapefile format of known time zones, so that if you know the location of your user, you can actually determine what time zone you're in. Is there any bare bones advice you can give me on that type of thing? Some way to not be stupid?
No, I haven't done that. But it's a very interesting and useful thing. That's
especially
good. I want that. Yeah, so that's good.
Yeah, especially with Django now actually having time zones kind of split off and forcing you to stay UTC native.
Right.
That's what's bringing it on for me.
Yeah. Okay. No, so that's great. I'm happy to hear that. So no, I don't have any advice for that. That's like more of a geolocation issue, really.
Okay. What about, so for test cases though, is there a list anywhere on the internet of all these magic dates that are really possibly throw a problem?
No, I don't think so. Not that I know of. No.
Okay, thanks.
I came in a little late, so I might have missed it if you said it, but do these routines have Julian days, things like that for astronomers built into them?
Sorry, what?
The Julian day function?
Yes, there is a Julian day function in the Python library. Yes, so you can get the Julian day out. I don't know if that is actually astronomer. Well, yeah, the Julian day should be astronomer compatible, because astronomers have year 0.
That's right.
Yeah.
Just to use an example, let's say you're not working in Python, but you're passing something like, let's say in JSON to something on a JavaScript front end. I tend to prefer a profile of ISO 8601 dates. What's your opinion on that?
Yeah, I agree. The ISO standard date format is a good date format for date exchanges.
Is that when you showed the iCalendar example? Is that a part of that?
No, I think that iCalendar is a different
very similar,
format.
but,
Maybe it's similar. I don't remember. I haven't thought about it.
Okay.
Yeah.
Thanks.
Well, it's similar that it has year, month, anyway, which is good.
Okay, so question 2. My company is using Project Open, unfortunately, to track hours, because we're a consulting company. And Project Open uses Julian dates. Why do they do that? Why would anyone use Julian dates?
The only reason I can think of is that its programmers have written, has decided like the user interface. Well, it's generally not a good idea.
It does not use them in the UI to its credit, but it does use them internally to represent dates.
Internally. Well, it depends on what is it written in.
I want to say it's PHP, but I don't recall for sure.
Yeah, but PHP has decent datetime handling support in that it's, default uses the Olsen database and stuff like that. But maybe the classes suck, and that's why they do it. But could be.
At least once you said you should store your dates in UTZ. Did you mean UTC?
Oh, so I mean UTC. If I say UTZ, I mean
okay, because I looked on Google and there was like this UTZ that was like George Bush getting confused about what time it was at his ranch, and it was silly. And I was like, he's not talking about that, is he?
No. Well, at least the important thing is to store it in a date that does not have DST changes ever. that's the most important part. So, and that becomes UTC, which, funnily enough, doesn't stand for anything. That's another of the funny things about.
We use the Julian dates to calculate growing degree days in agriculture.
Oh, okay. Interesting.
Okay, last question, I promise.
Yeah.
You mentioned quickly that you can create an iCalendar event that has no time zone. What does that do? Like, if I create an event that's like dinner at 6, and then I send it to a friend who's in Paris, does it say dinner at 6 on the calendar?
Yeah, it should then say dinner at 6 for him. Yes.
That's awesome.
So when it's dinner, it's not a problem because he realizes that you will realize that it's in your local time zone because it's at your place. But yeah, if you say then we're going to have a telephone meeting at 6, he'll think that it's in his local time. Yeah. So that's why generally UTC is better. The format that had the Z on the end. So you convert it to UTZ, UTC. UTZ, because it has Z on the end. You convert it to UTC and send it like that, and he'll should get it shown in his local time zone. But there's then no information of what time zone it actually happens in. All right. Thank you.
Anybody else? All right, thanks.